Okay, so we are launching this series of DataSpark Tuesdays, and the reason why we are doing it is because we have started our Databricks practice recently, and there are a lot of things that we are doing. We are learning new things, and if you see in the market, there are a lot of things going on around Databricks. A lot of organizations are trying to move to Databricks. There is good traction within APAC and across that we have seen, right? And first of all, to introduce this series, what we will be doing in this series is we will have weekly sessions. And some of the topics that you can see on the screen, the first three sessions is described like today we'll be going through why customers move to Databricks. I will be joined by Sumit later, who will help me with the demo. And the next one for the next week, we have Unity Catalog, and the subsequent week, we have Agent Breaks. So beyond that, we will continue to bring new things, and it will be a weekly session. And the session has kind of a framework where we start with a problem statement and we'll talk about what solution Databricks offers for the same. And the third and most important is what is the Unison offering around that. The reason why we are doing this because one, for the technical audience, it is good to have understanding of Databricks as a product, our service offerings as a product, what we are doing with some of the customers we have today, and how do we scale. And similarly, for the people who are in sales, it is easier for them to understand the technology, what are the use cases, and what kind of offerings that Unison have or what our team is doing right now. So to create this kind of awareness is very much important when we are dealing with, so Databricks is more around mostly technical topics. So it's good that we have that understanding. We have those keywords in mind when we are talking to the customer, when we are meeting the customers, or when we are designing a solution. So that's the intent behind the session. We will have solution offerings, product demos, and we will have a slot for Q&A as well towards the end of the session. So let's just get started that why it is important and why we are talking about Databricks. So quite recently, we have become Databricks partner, and the partnership is called DPP, which is Delivery Program Partner. And it is a specific partnership, and it's kind of a very elite club because if you see in Singapore or maybe in this region, there are only few other DPP designated partners. So we are one of the select few DPP partners across the region. And what that allows us to do is we work directly with Databricks Professional Services team. So for those who don't understand what professional services team does is, so let's say Databricks implementation needs to be done at a customer side. So Databricks team, their own engineers, their own architects will deliver that product. Now our team is working on those projects along with these people to deliver the project to the customer. So we are gaining that experience, we are gaining the expertise, we are understanding what are the framework or the best practices to work on a Databricks environment. So we carry that weight. And with this weight, right, uh, when we say in the market that we are DPP partners, yes, there is good traction. Even after we posted like one or two posts we did on LinkedIn, people started reaching out to us that you are DPP partner, and there were some opportunities floating here and there, right? So this holds very good credibility, and we should use this credibility. Okay, so that's why it's important to know what is DPP partner. So we are one of the few select partners. Now, while we are working closely with their professional services team, but we need to understand what else we can do with them. Moving on to our next section is why Databricks, why the customers are actually moving on Databricks. What is it there? Why everybody in the industry is talking about Databricks? So I've kept it very simple. So let's just understand that today, if you talk to any customer, be it a banking customer, insurance, healthcare, public sector, whatever, right? Uh, they have a lot of different tools to take care of different capabilities. Like they will have transactional databases, Oracle, and all those things, and they will have data warehouses, could be on Teradata. They have different data science system. They're probably using Control M, Airflow for orchestration. And for generative AI, they have other tools. And for reporting and everything, they have tools like Click, Power BI, Tableau, all those things, right? So a lot of things they have, a lot of different tools they have for different requirements. The data is fragmented, and for every tool that they bring in, they have to bring, so they are paying licensing licenses today. Then they have integration challenges within these tools. And let's say they want to scale their AI projects, that's where the real challenge comes. Their data is spread across multiple systems. They want to integrate all that data. Then they have to understand all the data through lineage and all those things. So they have to build a lot of uh, once, because these legacy system was built long back. Now the problem is, if they have a AI use case where they need to combine 2 to 3 systems, the problem is, how do you get all this data? One, second, how do you understand all this data? And third, how do you clean all this data for the use fit for the use case? So these are the common challenges across the industry, and that's why they want to modernize. And if I call out what are the top challenges that we see, one is, out of all these tools, the tool, uh, most of the tools, right? So, one, think about the integration challenges. The data is fragmented, plus, in some cases, data is duplicated also. Like there is redundancy. The same data can be available across many applications. So, it's just they are paying unnecessary costs, they're maintaining unnecessary copies of data, and all those things. They have a legacy debt. That means they have systems which are quite old, and it is very difficult to scale, or it is very expensive for them to scale those systems. And then comes the license cost. They have to pay license cost no matter how much they are using and how much they are not using. And their current system probably lacking some of the modern capabilities like AI, ML, LLM, whatever, right? All those things we are hearing, agentic AI and everything, those capabilities are lacking. And that's where Databricks comes as a platform which can take care of most of the things that requires through a data lifecycle. So the session will go a little bit technical from here, but I'm happy to answer any questions that you have. Okay. So first of all, what Databricks do is it decouples the storage from the compute. That means you can keep your data in the open formats, and you can keep it anywhere. You can keep it in terms of Parquet files on S3 or ADLS or whatever, right? Any object storage. So that means the storage is entirely decoupled. You can store data in any format, any place you want. Then comes whatever data is available through all these things, right? You can bring it to a unified governance layer, which is Unity Catalog. We have a session for the Unity catalog coming up next week. So details will be shared there, but we'll just touch upon this. It's like a catalog where you can see all the assets within your data ecosystem. It could be tables, it could be jobs, it could be your ML workflows, it could be your knowledge assistants and whatnot. So all those things, and then you govern the access to it. That means Sunit can probably see only Singapore data and not India data. All those kind of things you can manage through that, right? So that is the basic things. So I'm going bottom up. Now, if you look at going bottom up, there's another thing called Lakeflow. This is where, so back in the day, you have seen Spark and everything. Code was written in Spark. Even today, a lot of Spark jobs that you see. And then you have some ETL tools to bring the data in, to transform the data, to manage the data quality, all those things. So that comes as part of Lakeflow. So in Databricks, it is managed through Lakeflow, but Databricks do understand it works on the principle of Spark. So it's more around it can understand 90% of the Spark, but 10% it brings some of the key features which which differentiates itself from the Spark. That means some of the modern features. So it's kind of Spark plus plus, I would say. And in terms of massive processing, it can take care of that. There are two architectures. If we talk about here, we have Lakehouse and Lakebase, where Lakehouse is suitable for data warehousing kind of workloads, where you create your Medallion architecture, you create your gold layers, and on top of that, you build your dashboards or you start your query engine or whatever, right? And then comes the Lakebase, which is a serverless Postgres, which can take care of your workloads where you require quick access. Like you want the response time, which is a quick, faster response time. So that's where the lake base come into picture. So once you design your data engineering job and everything, and you have data available in lake base or lake house, the next thing comes is Genie. So Genie is more around their AI, I would say, assistant. And what it can do is it can help you query your data. So in a bank, somebody can ask which of my branch is giving out more loans in the last quarter. They have gave out more loans in last quarter. So you just ask the question in natural language. You don't have to write a SQL query, or you don't have to go to a dashboard. So those kind of problems Genie is solving. There is a version of Genie which supports Genie code. So Genie code, what it does is, while somebody, a data engineer or ML engineer is doing some task on Databricks, and he needs some help with the coding and everything, he can just give a prompt and it will help there. So that's the next thing. Uh, if you go on top, starting there on the left hand side, it called Agent Bricks. So Agent Brick is most around their ML and AI, LLM, GenAI capabilities. So it start with all ML ops, all those capabilities there. Then they have agentic capabilities. They have some out of the box feature for processing documents. And then it allows you to build your agent, your architectures, your agentic workflows. All those things are available there, and you can integrate with any kind of LLMs which are openly, or some of the models which are available, like from Claude, Anthropic, all those things you can integrate there. AI/BI is more around dashboarding, similar to Click, Power BI, Tableau. So those capabilities are there. And then there is another concept of building custom apps. So if you want to build an entire app which requires data to be processed first, and after that some agents to be working in the background, so all those things you can do it here. Now, we were talking about what are the problems that Databricks is solving. So on the last slide, we talk about certain problems. Now let's talk about what are the key features that Databricks provides. So one is, if you see on the top, there are modern features available. Like if you have to do ML, GenAI, LLMs, right? And even if you have to build enterprise governance of the data, which is coming across. And later in the Unity catalog, when we cover, you will see that it has the capability to fabricate the data. That means you don't even have to bring the data, but you can still query the data from here. You still see the data from here. So those capabilities are there. So those are modern capabilities. Somebody wants a modernization. Somebody wants to, go strong on their AI journey. So that's where they choose Databricks. The other reason is performance and efficiency. So with some of the legacy application, there are certain performance challenges, and because here you can scale you can scale workloads when it is needed, and then you can calm down your systems whenever required. So it offers serverless and all those capabilities. So elasticity, we call it. So all those things are there. Another thing, it reduces the redundancy, which is data in multiple siloed system. You don't have to go there. You don't have to maintain multiple copies there. And the third most important is it provides velocity, because if data is available in a single layer, it is easier for uh, data engineers, for data scientists, for um, AI engineers to access the data. So it brings the velocity to whatever you're trying to build. So those things are very much important for in the age of AI. And then because it kind of decouples the storage with the compute, it brings you to a lower TCO. And also you can exit the licenses that you're paying probably for Teradata, Oracle, or maybe some ETL tools, Informatica, Talent, or any other thing that you're doing, right? So you exit the license. So let's say your use case requires only to run once a month, and you don't need to pay the license fee for the entire year, right? If you are running something only for 12 days, uh, then probably you go to Databricks, and you will be charged only on the consumption that you did for those 12 days. So that's where a lot of organizations think of saving cost. And then there is a modular approach. It's not necessary that if I'm using Lakeflow and Lakehouse, I have to necessarily go to Lakebase, or I have to necessarily build a dashboard. So you can take a modular approach. Whatever feature you want to use, you can just use that feature. So those are the cases.
Hi everyone. So as a part of this demo, I'll just do the actually data ingestion to Unity catalog table. So as a part of like this one, I'll be just giving a demonstration of how the ETL pipeline works here as a part of Databricks. So the step will be that I'll just have a raw CSV file that will contain the data, and using our ETL pipeline, I'll ingest the data and bring it to the Unity catalog table. And this pipeline will have the strength of incremental ingestion. So it means that if afterwards if I'm adding any more data, it will incrementally get added that one, and automatically this will get invoked. So before starting my demo, let me share my screen. Okay, fine. Yeah. So as a part of this actually demo, so first let me just elaborate this table structure. So my actual demo will be that we'll be ingesting some raw CSV file, and we'll be just bring out this data as a part of this table. So this is basically, if you see here, there's a Unity catalog. So this is where our schema resides, and all this table that we create inside this one. So for this demo, I have just created one table, which is a customer table, and this is the attributes which have. So right now in this table, there is no data. So I've just taken this custom attributes like customer ID, custom name, email, and country, and actually all these stuffs. So as a part of this one, let me just open my actually sample data points as well. So if it's so actually as a part of this CSV, let me just open this one, and I'll just explain a bit about this one. Yeah, so this is my actually data point, this one. So if you see this in actually this CSV file, we have this customer ID, customer name. So as a part of my orchestration, I'll ingest this CSV data, and all this data should get actually added here as a part of this table, right? Yeah, so that will constitute this actual presentation, and for this I'll be using uh, orchestration actually ETL pipeline for that. So actually, as you can see here, I have already created this actually pipeline. Okay, so as a part of my actual pipeline, we have this Databricks notebook. Okay, and this Databricks notebook contains actually all this piece of logic. So the Databricks notebook will connect to the CSV file. It will retrieve all the data, and after getting the data, it will push this data to Unity catalog table. So this code I have implemented here as a part of that one. So yeah, so this orchestration pipeline will connect to this Databricks notebook, and it will connect to the CSV file, and after that it will just ingest the data. So that will be my actually step of execution. So as a part of this one, actually, as you can see, this is my ETL pipeline. Okay, so I have just only one actually task here. I should pardon this name because spelling name. Yeah. Okay. So as a part of this one, actually we have this pipeline which contains only one activity, and this activity is basically the notebook execution. Whatever notebook is there, this notebook itself contains this actual piece of logic. So this actual notebook will actually execute it here. Okay, and right now I have configured this notebook that as and when the file arrives, so I'm not going to start this notebook. This pipeline will automatically get executed. So the thing is that this execution is actually defined that whenever any CSV file arrives, this notebook will automatically, and this pipeline will automatically get executed. This will execute the notebook, and all this data will actually get ingested, right? So as a part of this one, yeah, so in the meantime, actually, as you can see here, this file arrival, we have put this actual location. So this is the actually location where we'll be uploading this CSV file, and once this file gets uploaded, actually, as you can see, this pipeline will automatically get executed. Okay, so let me just upload this actually CSV file here as a part of this one. Let me just go to this Unity catalog here, and actually, as you can see, this is my actually volume demo, and after that I'm just going to upload this actually file. Okay, so I'm just going to browse it here. I'll go to that CSV file. Let me just go to that one which I'm going to upload here. As you can see, this is the file which I have opened it here. I'm just going to open it here and actually upload it here. So as you can see, once this upload is done, right, and I'll just go to my actually pipeline, and I'll go to just execution tab here. Okay, so I have to just run it manually at the start because I have just modified this one, this name. So first time I need to just execute it manually. Okay, and if I query this actually able, let me just go to this one, right? So at start, as you can see, there is no actual information. So whatever actually data is there, that is not there at the start. So once this processing is completed, whatever the data is there as a part of CSV file, that should get added here. So let me go to our actually pipeline. So as you can see, this pipeline is executing now. Once the execution is complete, I'll just go to that actually table to actually visualize the data. So let me just wait for a couple of seconds here. In the meantime, maybe we can just go through this execution as well. So if you want to see which code is getting executed, yeah, so actually, as you can see, this piece of code has been executed right now. The execution is going on, and this is completed, as you can see here. So let me go to this one. So this execution is completed, and if I go to my actual table, let me just go to this actual table, and after that, if I just query this one, this yeah. So actually, as you can see, whatever this CSV file were there. Actually, all this record got actually ingested here. And as a part of this ingestion, I have also included this file name as well, right? As you can see. Now, so we uploaded that actually CSV file and that pipeline executed, it processed the data. Now, what I'm going to do is that I'm going to upload one more file. So as a part of this one, once I upload one more file, I don't have to execute the pipeline. The pipeline will automatically get executed. Okay, so let me just go again here as a part of this one, this actual demo. Let me just, just upload one more file here. So I upload to this volume, and I'll just upload another file apart from this one. So I have already uploaded that one. Let me just upload this one, underscore one, right? If you go to open here, and after that I'll just upload it here. Let me go to our retail pipeline. Yeah, so actually, as you can see here, after some time, this will automatically get actually executed. So I'm just waiting for a couple of seconds here, and there will be automatic execution here. It takes a couple of seconds to actually execute and actually invoke this one. So I'm just waiting for some time, and let me refresh this
I
one.
think
Yeah.
if you have noticed, right, we are running Spark code again in here. So it's the data engineering pipeline, one of
Yes.
the data engineering pipeline which Sumit is showcasing here. The code is again Spark based, but it can be executed in Databricks, and he will cover later what are the rest of the capabilities that we have on Databricks platform. Yeah,
Okay, sure, Sunit. Yeah. So it seems that it got executed.
yeah, it's running.
Yeah. So it says it started the execution, as you can see here, pipeline run. And once it's complete, I'll just again go to this Unity catalog table, and that actually data which contains in this file that should get appended there. So I'll just wait for some couple of seconds. It should be done in around 50 seconds. On an approximate takes that one. Okay, so actually, as you can see, this pipeline execution is completed. If I go again to that actually SQL query which I've executed before. So as you can see, before we have this actually file name, right? 10 records. Yeah, after that, if I just execute it once again, and then we'll have that actually another as well. So as you can see, now initially it was this one. I just added this incremental underscore one file. So this additional actually record came as well. So in this case, the idea is that whatever the user is uploading the file, only that incremental data will get processed. So this pipeline will get invoked automatically, okay, based on whatever file I'm adding, and it won't process the already processed file. So whatever the file has already been done, it is going to skip those files. So as you can see, it's one actually came. I can just add one more actually file here as a part of this demo. I think after that it should be okay. So let me just add one more file, upload one more file. So underscore one I have already done, and let me just add underscore two. That's the incremental one, right? So here also, as you can see, if I'm uploading here, after that actually I don't have to do anything. This pipeline automatically actually finds out, as you can see here, this is the actually storage location. So I have just uploaded here itself. Once I upload it here, then pipeline actually, as you can see, this has actually started this processing of this file. So once this is done, then after that, this data will also get appended as a part of Unity catalog table. So in this case, it happens everything automatically. Yeah. So I'm just waiting for this, and again 50 seconds, and after that I can just execute that SQL code to. Yeah, so in this case, it got run in 32 seconds itself. So it happened quick this time. Let me just go to here. So as you can see, initially is what load underscore one. If I just run again, so another entry will come. That's underscore two. Actually, as you can see here. So yeah, we have got this data now, previous data and previous to previous. So in this case, we can just actually configure our Databricks pipeline to actually incrementally ingest the data. Yeah, that's all actually for this demo. I mean, please let me know if you have any question related to
Amit,
this.
will you give a walkthrough of all different capabilities that are available in the platform? Just a high level.
Okay. Okay, fine, sure. Yeah. So actually, as you can see here, right? So let me just let me just start with catalog actually here. So as a part of Databricks, as you can see right here, we have this actually catalog. So catalog, let it open. Okay, so actually in this actually catalog, the way it happens is that there is a catalog at the start. Okay, within the catalog we have a schema, and within this schema we actually define out tables, right? Actually as you can see here. So generally what happen if you go to SQL server, Oracle server, we have a schema, and then within the schema we define these actually tables. But as a part of actual Databricks, we need to define one catalog as well, because catalog is important, because catalog it's most of a like it can be development environment, for example. So for that we create a catalog for actually dev. Within that we create a schema. If similarly if you go for UAT, so we create a actual catalog for UAT, and after that we define the schema and actually their tables actually respectively. So in this case, like depending on our business use case, we define the catalog, we define the schema. Yeah, that's actually completely onto us. So this is the catalog which is which actually stores the data. And now actually, as you can see, sometime back, Sunit explained that okay, this is actually external storage. So in catalog we have both option, where we can define the storage not as a part of Databricks, external table basically. So storage can be as a part of Azure, where the actual data will be residing. Compute can be here. So for example, here if we can go for customer actually tables here, right? So actually as you can see here, this customer table is defined as a part of Unity, but the storage location is there as a part of AWS. So yeah, so as you can see, it resides the data as a part of actually AWS. So in this case, the storage cost doesn't come from Databricks. Storage cost is being calculated by AWS S3. Right, so Databricks provides the compute, but the storage comes from either if we are using Azure, then Azure actually Redis, or it can be AWS or actually GCP. So this is the structure generally. We can also have the storage as a part of Databricks, but mostly commonly actually practice is to have the storage as a part of our AWS or actually Azure or actually GCP. So this is a Unity catalog. If we see this capability where we define this actually job and pipelines. So here we define our orchestration ETL pipeline. So as you can see here, we can define our ETL pipeline, we can define our jobs as well, and ingestion pipeline. So there is some incremental right now. Databricks is adding many more capability as a part of ETL. So here, depending on our use case, whether we are doing batch ingestion or streaming ingestion, we can just define our pipeline, and this pipeline will just execute your orchestration, and it will just bring the data from your data source and put to as a part of Unity catalog. Okay, so here for all the job and pipelines, we just define as a part of this one. If you go to compute here, as you can see here, so compute is basically where we define clusters actually. So this cluster is actually the compute one, which is actually doing this data processing. So whatever execution happen, that is being done by the cluster itself. So as a part of this cluster, we can define our actually SQL related cluster, job related compute as well, right? So for this cluster, we just go for here as a part of compute. So for example, if I go for create compute. So in create compute, basically we just define the cluster name. We define on which Databricks runtime we want to do it, right? So here we can define what is the actually cores, number of cores, their actually memory, all these things we just actually define. We define the auto scaling depending on if the workload is high. This can be scaled as well automatically. Enable auto scaling. We can also defining if there is no cluster usage which not incur cost, right? So for that we define this minute of inactivity, that if there is no activity done within this 120 minutes, the cluster should stop, otherwise it will just keep on incurring cost, right? Yeah, so all this configuration basically we define a compute. This is actually very important, because if you want to have a good performance and good performance, so accordingly we should be able to define our compute accordingly. But here we need to also consider that if we define a very high compute, the cost will also be high. So depending on our use case, we need to just decide about the compute capability. Okay, so one second. Yeah, yeah. So this is the compute actually, and now after that, if you go to actually marketplace, so marketplace, it has got a lot of actually marketplace where we can bring this data. So as you can see here, we can bring the data from actually Meta, SMP, Global Market Intelligence. So marketplace where we can get some actually data sets, get some actually MCP, model context protocol as well, right? So as you can see, there are a lot of API which is being provided by our actual partner connect. So if I want to connect to Power BI, for example, so we can use the Power BI desktop. This will provide the connection string. Using that, we'll able to integrate the Power BI with our Unity catalog. So data will be residing as a part of Databricks, but using this connection, we'll able to display the data as a part of Power BI. Similarly for DBT Cloud, actually Tableau, as you can see here. So a lot of things are actually provided. So basically, these are marketplace means external actually platform apart from Databricks. If you want to get any data, if you want to get any kind of reports, we'll able to do it. Sure, yeah. Okay. So as a part of this one, actually SQL editor. So let me just copy this table. So SQL editor is something where we can just write our query, for example. So as a part of this actually query, whatever creatable actually scripts we have to define. So either we can run this as a part of notebook, or you want to run directly as a part of this SQL editor, that can be run. So here we can just write any of the select statement, update anything. I mean this query also can be run as a part of notebook, but notebook actually is not that scalable, because for that you need to create a notebook and you have to just execute it, right? But here, anytime we can go to SQL editor. So yeah, and after that, we can just execute these actually queries. And at the same time, whatever query we are creating, if we want to save this query. So yeah, actually all this query, historical query are actually coming here itself, so that in future you want to go back to any historical query, we can just go to queries and actually open it. For example, if I open this query, whatever I have done some time back, it will. Yeah, so that can be accessed it. In the meantime, if you want to save any query by actually giving any kind of name, that should also be fine here as a part of this one. So as you can see, we can create a query, we can save the query as well. In as a part of dashboard, so it is exactly similar to actually Power BI. So here the thing is that we want to create any kind of dashboard which connects to our Unity catalog tables, we'll able to do it. So this dashboard is also getting upgraded a lot, AI BI dashboard. So whatever dashboard you see as a part of actually Power BI, same kind of dashboard we can create as a part of our actually Databricks as well, right? So we have this actually option to create the dashboard. If I just go to actually dashboards creation, then in this case, first we need to define this actually data means either we can define our actually table itself, or we want to define some kind of queries. So for example, if I write this one, right? So here whatever we want to define actually SQL query, that query output will be actually this, this actually data for this actually dashboard. Okay, and yeah, so in this case, we'll able to create our own actually dashboards. If you go to this actually Genie is basically we want to just ask any kind of question, so we can point to any of the tables. Actually, as you can see here at the rate, so any kind of question that you want to ask. Okay, give me this table name. Can you just tell which is the actually highest employee number and actual kind of thing. So any kind of analysis related query, we can just write in actually plain actually text, and we can just ask actually Genie will able to provide those answers. We have this actual alerts as well. So create alert we can do. The create alert is basically kind of actually SQL query, where we can just actually define if the SQL query is actually what you call completing fine, then we should invoke this kind of action, or we should give some kind of notification. So actually, as you can see here, we define the alert condition. Based on when the alert condition is actually met, then we also define this actual notification. So notification can be our email notification, it can be our Microsoft Teams notification, right? So whenever this query runs, it satisfies any kind of condition, then the notifications are actually invoked. So for those things, we can just define as a part of this actual alerts. Query history is the kind of thing, right? Whatever query I have executed, right? Actually, as you can see, whatever the historical query I have done, everything is actually coming here as a part of this query history. SQL warehouse is something that this warehouse we use to execute the actually SQL query. Okay, so we create our SQL warehouse. So actually, as you can remember, this actually job compute was for orchestration, right? So whatever we ran the ETL pipeline, that was utilizing this actually compute. But whatever query we are running as a part of SQL editor, for that we need to create these SQL warehouses. So SQL warehouses is also a kind of compute, but it is specific to running SQL queries, right? As you can see, we can create SQL warehouse as well, and we can give the name. We can just define our cluster size. Depending on that, we want to have a small query like 4 db per hour or 12 db per hour, depending on our workload, whether we are running frequently query or we are not running frequently query. We just define this cluster size as well. Auto step also here. So if I'm not running any query for some time, it should stop it. Scaling also min and max. If the query is very complex, we want to increase this scale of that one, we should able to define it. Yeah, so here also this actually type is there serverless. It means that this we actually don't define our actual cluster. This cluster comes directly from actual Databricks. So we have both option. Either we can define our own cluster, or if we don't want to define cluster, we can go for this serverless option, where it is being provided by Databricks itself, that compute capability, and using those compute capability, we can execute the actual SQL query. Yeah, so as you can see here, we have advanced option as well, whether Unity catalog channel and everything. Yeah, so basically this whole idea is the SQL warehouse we used for execution of the SQL query, providing the compute for that. If you go to data engineering track, we have this execution. So whatever the previous pipeline we just want to see, everything can be actually visualized here. We can just give the pipeline jobs all. We can also filter that we want the pipeline run 2 months back, for example. So we can just define the range here. We'll able to see all the historical run here as a part of this one. Data ingestion is also something. So here actually, as you can see, data ingestion. So basically Databricks provide a lot of connector. So if you want to bring any data from the Salesforce SQL server, for example, Workday report, right? So if you have a data which is external system, right, it can be residing in actually SAP Business Cloud as well. We can just connect to that using connection strings, right? And those data we can bring as a part of our Unity catalog table. So Databricks provides actually a lot of connections here, as you can see here. So Oracle, actually Dynamics 365, Data, HubSpot, right? So using those one, we'll able to connect to those actually data sources, and we want to bring those data as a part of our Unity catalog table as well. Yeah, so this is a more or less the complete actually data engineering part of that. And below, as you can see, it's a more of related to AI ML feature, where we can define, create agents, we can create AI gateway, experience feature, yeah, and actually all this stuff. So for data engineering, basically we are just concerned about those things, which I just actually explained. No, yeah.
So
Thanks,
just to
Sunit.
summarize, right? So Sumit covered most of the things from the data engineering perspective, starting with the jobs, the data, where the data resides, how it take care of open formats, data can reside in S3, all those things, right? Then he also covered some of the things on the dashboard side, relatively like Power BI. Somebody has to create dashboards; those capabilities are also available here. Then Genie as well, and also ANML. Now, today's session was more around giving you a high level detail about the things that Databricks as a platform has to offer. And in the subsequent session, we will be picking up topics which are of interest and of importance, and we'll do a deep dive in probably some of the things. Like next one, we are going deep dive on catalog, and the subsequent one, we are going to, doing a deep dive on agents. Thank you very much, everyone. Thanks a lot for your time. I will be sharing the recording as well as the deck used in the session for your reference and for future reference. Thank you. Thanks a lot for joining the call.
Thanks, everyone.
Thank you, everyone. Thanks, Sunit.
Thank you.
Thank you.
Thanks, Sunit.